and the direct methods were by taking chlorine and Lewis acid or bromine or Lewis acid. But I told you that direct chlorination is not possible because fluorine is exothermic. So we prepared fluorobenzene by Shishman reaction, right? And what this Shishman reaction is, this is an iodobenzene also was prepared by Shishman reaction, and this reaction is actually the synthesis using disonium salt. Okay. So in disonium, you take benzene, you convert it to nitrobenzene, you reduce it to aniline, and then you make it disonium by heating it with NaNO2 plus HCl between 0 to 5 degree. Sometimes nitrous acid is also given. Okay, and you heat it with HbF4, and that will give you fluorobenzene. Same is with iodobenzene. Iodobenzene you can't get directly because the reaction is reversible. So that in that case, you heat the disonium, you prepare the disonium by this whole process, and you heat it with Ki. That's what we discussed. Okay, clear? So yeah, and to put Cl and Br, we were having two methods. Okay, we were having two methods. One was Sandmeyer and another was Getterman. Okay, and what was the difference? Harpreet and Imad, Sandmeyer and Getterman. Yeah. Sandmeyer and Getterman. Anushka, what was the difference? In Sandmeyer, we treated disonium with copper salt, CuBr and HBr, okay, or CuCl plus HCl. But in Getterman, we took copper powder, right?
Yeah.
Okay, so that's what the difference was. Now we will look at the physical and chemical properties of alkylites. So we need to consider what type of bond do they have. Okay, so alkylites, suppose the smallest alkyl group and on which the halogen is attached is CH3, which you get from methane, and you react it with chlorine or bromine. Okay, so with that you get CH3Cl or CH3Br or CH3F. Okay, that's the smallest alkyl halide. Okay, or F fluoro. So in order to discuss the physical and the chemical properties, you need to understand what type of bond are they having. Okay. So can you tell me what this bond is? Yeah, Anushka. Anything, or Imad, Arpit?
Single bond?
Carbon chlorine bond. Yeah, what nature will it have?
A single bond.
It is single bond.
Single bond.
Anything else that is correct? It is actually a polar bond. It is polar in nature. Yeah.
So what was the meaning of polar bond? Like, can you just explain it, please?
Yeah. Suppose if you have chlorine bond between Cl2.
Okay.
So both the atoms are same, and their electrons will be, the bonded electrons will be exactly in the middle, in the center. But if you take carbon and chlorine bond, chlorine actually it is more non-metallic character because it is having 7 valence electron. So it has more tendency to pull the bonded electron towards itself.
Okay.
So the electron pair will not be exactly at the center, it will be towards chlorine. Like this. Okay. So it will, because the electron density has shifted more towards chlorine, the chlorine will acquire partial negative charge, not complete negative, because I am still not breaking the bond completely and making it Cl minus. The bond is still there, or you can imagine it in this way also. Okay, in the chlorine and chlorine, the electron density is actually at the center, right?
Yes, sir.
And in carbon and chlorine, the chlorine is more electronegative and it has more tendency to pull the electron towards itself, bonded electron pair, and that is known as electronegativity.
Okay.
Okay, so chlorine is more electronegative, so this electron cloud, I have made it not symmetrically oval, I have shifted it towards the chlorine. So chlorine is more electronegative. Due to which the chlorine has more tendency to withdraw bonded electron pair towards itself. As a result, the chlorine will acquire partial negative charge and the carbon will acquire partial positive charge. Okay, so this type of bond, Arpit, is known as polar bond.
So normally chlorine is more electronegative compared to CH3, or just
Yeah. Chlorine, the electronegativity of chlorine is 3.
okay.
There are numbers given, and carbon is 2.5. The most electronegative element is F, fluorine. Okay. So it is polar bond, and because of this polar bond, we also write it like this. CH3, Cl is there. We write it like this. We put an arrow, and you can notice the tail of the arrow is having a plus charge. Okay, means the electrons are getting shifted towards, bonded electrons are getting shifted towards chlorine because chlorine is more electronegative than carbon. Okay. So this is polar bond, and it means that carbon chlorine bond has and polarity is measured by charge into distance, and that is known as dipole moment. Okay,
So,
it's a dipole. Yeah, Arpit.
so can you explain?
Yeah, Arpit.
Sir, I was asking, like, can you explain again that what does this arrow represent?
This arrow represent how the electrons are the bonded electron pair. First of all, if I put arrow, it means the bonded electron pair are not equally shared by both the atoms, and they are more shifted towards one side. Okay,
Okay, sir.
so because they are shifted towards chlorine, I have put the direction of arrow towards chlorine.
Okay, sir. Got it. Got it.
And the tail is plus charge because that will acquire, the carbon will acquire partial positive charge. Okay. So alkyl halides are polar molecules and they possess dipole. They are like dipole. Dipole is actually, in physics also we study dipole. It is like this, plus and minus. There are two opposite charges. Okay. So it behaves as a dipole. So suppose if you take two molecules, what type of attraction they will have? Suppose what type of interaction is present between Yeah, what kind of interaction they will be having? Yeah, Anushka, Himad, Arpit.
The dipole,
Yeah, dipole attraction.
so why dipole and why not dipole?
Yeah, actually one dipole is the positive end of the one dipole is getting attracted toward the negative end of the another dipole. Okay. So actually these dipoles are attracting each other. So that's why we will call it as dipole attraction. Is it clear?
Yes, sir.
So which one will have more boiling point? Ethane or CH3Cl? Yeah, Anushka, any idea?
The CH3Cl.
Yeah, why?
Sir, because chlorine has more.
Chlorine is more electronegative. So
Yes,
suppose
sir.
if you take ethane, ethane will be CH3CH3. Okay, that is ethane. So ethane is CH3CH3, and will it be polar?
No, sir.
No,
No,
sir.
because both are carbon atom. So it is a non-polar molecule. And CH3Cl is,
Polar.
yeah, it is polar because there is an electronegativity difference, and because of this polarity, the intermolecular forces are stronger. Okay, stronger dipole attractions. But what about this alkanes? They do not have permanent dipole moment, but they can have ins just temporary dipole moment for some instant of time, for a particular instant of time. Suppose if the electron temporarily moves from one side, so they will have just for a fraction of second. Okay, not permanently. CH3Cl is permanently polar. It is having minus and plus. But ethane molecule is non-polar. Permanently, it doesn't have a dipole moment, but it can have, just because the electrons are moving and at one moment of time, suppose the electron come on one side. So CH3 can have temporary instantaneous dipole. Okay. And so but that is going to be very weak, and just it will disappear. Okay, in just fraction of seconds. It is not permanent. So those are known as dispersion forces or van der Waals forces. And they will be weaker. Okay, van der Waals forces will be weaker. Okay, and what kind of van der Waals forces? They are also known as London dispersion forces or dispersion forces. Which are very weak. Okay, because they do not have permanent dipole moment, so the molecules are not holding each other together. They can escape out very easily. Is it clear? So that's why it is having low boiling point, and this one is having higher boiling point. Because if you need to boil it, you need to overcome the forces of attraction, then only the molecules will get into the gas phase or the vapor phase. So if the forces are strong, that means, Arpit, what? The boiling point will be higher. Exactly. So alkanes are less polar, means alkanes are almost non-polar, not say it like this. So they can turn into gas more easily. They have lower boiling point. They can escape more easily because the molecules are not holding each other strongly. On the other hand, alkalites are more polar. Is it clear? And what about water? What about water? What kind of forces are present between two water molecules? So water is H2O, yeah.
Polar.
Yeah, it is polar, but you need to say one more word. And that will be useful in your alcohols and ethers chapter also. Oxygen is more electronegative, okay, than hydrogen. The electronegativity of oxygen is slightly more because it is the one which is on the right hand side of the periodic table are more electronegative, more non-metallic. Non-metal want to accept electron, that's why they are non-metal. And hydrogen is on the right and left hand side, okay. So hydrogen will have tendency, it will not have that much tendency to pull the electron. So oxygen will pull the electron from one hydrogen. So the electron pair will not be in the middle, it will be towards oxygen. So oxygen has more negative charge density. I'm writing it as partial delta, means indicating partial negative charge on oxygen, and H plus, okay. Similarly, this bond is also having partial charges on H and this one, right? So the oxygen, this is also having a dipole moment, right? Is it clear? So another water molecule will also be there. That will also have a same kind of thing. That will not be different from this one. Himad, is it clear?
Yes, sir.
Arpit?
Yes.
So these are dipole, but I need to say some special word. I need to hear, Anushka, one special term. What
Yes, sir.
that's I need to hear one special term for it. What that special term is going to be? Yeah.
The
Himad?
dispersion force.
No, it is not a dispersion force. It is much stronger than dipole. It is much stronger than dispersion, though it is dipole, but a special kind of dipole. It is known as hydrogen bonding. Hydrogen bonding is a special case of dipole attraction where the positive end is H plus. Clear?
Yes, sir.
So it is, and it is much more stronger in terms of energy as compared to dipole also. Okay, so you can have an idea now. Okay, this is H bond. In short, it is known as H bond, or in this you can write H atom. So which type of hydrogen exhibit H bond? Himad?
Yes, sir.
H atom directly connected to
Uh,
Directly connected to whom?
Dipole.
Yeah, most electronegative atoms. Okay. H atom directly connected to most electronegative atoms, and the three most electronegative atoms are F, O, and N. Is it clear? So H bonding is going to be stronger than dipole-dipole attraction. Okay. So water will have more. Water will have more, Anushka, boiling point. Okay. You can see here, right? In this melting and boiling point section, the physical properties. I hope everybody can see
Yes.
your NCERT book.
Yes, sir.
So first of all, in alkalite, the boiling point is like this. This one. It is because they are polar, and as you are having heavier and heavier halide, means iodine is much heavier than bromine because of its larger atomic mass, 127. The bromine atomic mass is 80. Chlorine is 35.5. So as we are having higher and higher halides, okay, the boiling point is going to increase as long as you have same alkyl group because of the increase in forces of attraction. Okay, is it clear?
Yes, sir. So then, what does this graph represent here?
Yeah, graph represent the boiling point. For
Okay.
example, CH3X, right? The red one is actually chloride, CH3Cl, then this is CH3Br and CH3I. So intermolecular forces are increasing, van der Waals forces are increasing. Okay, that is because of the increase in mass and size. As iodine can have more attraction with another CH3I molecule because iodine has more number of electrons. It is a bigger atom, large surface area. So this is one thing. Okay, they are all polar. Okay, is it clear? But when it comes to their water solubility, okay, water solubility, the alkyl halides are going to be almost insoluble in water. Why? Very slightly or almost insoluble in water. What is the reason? Yeah, tell me. What is going to be the reason for the insolubility of alkyl halides in water? When something becomes soluble.
So
Yeah.
alkyl halides are not soluble in water is because they are not easy to break. They bond.
Actually, suppose if you are mixing two things and they will become soluble only when the new type of interactions which appear are stronger than the interactions which were present in the original substances. Is it clear? So A and B, A and B. Suppose there are two liquids. And if you mix them, you will have molecules of A in contact with the molecules of B. Okay. And when the mixing can occur, if the interactions new interactions which are between the A and B molecules are stronger, than the original interaction. If the new interactions are stronger than the A interaction and BB interaction, then only the mixing can happen. Okay. So will alkyl halide mix into water? Imad, Arpit?
No, sir.
Yes, sir.
No, because hydrogen bonding is stronger. Okay, it is stronger than the dipole-dipole forces. Though hydrogen bonding is also a type of dipole-dipole, but you have the plus on edge, so that's why the plus is able to combine very strongly with another partial negative charge. So alkyl halides are insoluble or almost very less soluble in water because the interaction in water molecules between the water molecule before mixing are stronger, and that interaction is hydrogen bonding, and that interaction will not break easily, and that will not let the alkyl halide molecule to get between the water molecule, because water molecules are holding each other very strongly. Okay, so that is the reason why you have very less solubility. Is it clear? So I hope
Yes.
this is clear, hydrogen bonding, but this thing is very, very important. It will be used in all the chapters, subsequent chapters. Okay. So this you need to remember. The next thing is, suppose for fluoride, chloride, bromide, and iodide, if you have same alkyl group, okay, if you have same alkyl group, and as you move from fluorine to chlorine to bromine to iodine, the intermolecular forces are going to increase because an increase in number of electron, increase in mass of the substance. Is it clear? So the boiling point is going to increase. If you have same carbon group but different halogen, the heavier the halogen, the higher will be the boiling point. Is it clear? Due to increasing van der Waals forces. Okay. But for the boiling point of ethane, CH3Cl, and water. So what will be the order of the boiling point for these three? Yeah, Arpit? Imad? Yeah?
No idea, sir.
Boiling point, this is almost non-polar.
So, but how can we determine that, for example, if this is non-polar or this is polar?
Actually, this is carbon-carbon bond only, the middle bond.
Okay.
And the other bonds are carbon-hydrogen. So carbon-hydrogen have almost very same kind of electronegativity. So that bond is almost non-polar. Right?
Yes, sir.
Arpit and Anushka?
Yes.
Yes,
So
sir.
between two non-polar molecules, what kind of forces are they having?
Dipole.
A temporary dipole. They do not have permanent dipole. Temporary dipole, instantaneous dipole. Okay. or dispersion forces. Okay, right? They are very weak, the temporary dipole. They are not permanent. And what about this one? Arpit, Anushka, Imad, tell me. What about CH3Cl? What kind of forces will be there between the two CH3Cl molecules?
Polar.
Dipole.
Yeah, polar, dipole. Correct. So it is a polar molecule and it is a dipole interactions will be there. Right. And what kind of interaction will be there between the two water molecules?
Hydrogen bonding.
Hydrogen bond.
Edge bonding. It is a special kind of dipole edge bonding. So it is much stronger than the dipole interaction. Always remember this. Okay. So as you have more and more, as you are moving towards stronger and stronger interaction, the molecules will be held more strongly and the boiling point is going to increase. So the boiling point of water is greater than CH3Cl and CH3Cl will be higher than alkane. Okay, right? And
Yes,
if
sir.
you have same alkyl group, then fluoride will have lowest boiling point. Fluoride boiling point than CH3Cl and CH3I will have maximum. Right, Arpit?
Yes.
And if you have same number of carbon atom but different types of carbon chain, then how can you compare the boiling points? If R is also alkyl group, has same number of carbon atom and the halogens are also same, then how can you compare the boiling points? Yeah. So it is not like this one. Okay, in that you can consider the surface area. Okay, this molecule, the molecule which is linear. Okay, all the carbon atom, there is no branching, they are connected one after another. So it is a linear chain, long chain. And suppose if the Br is connected in the middle, so this is a branch chain and this is much more branched. Can you see this? So same molecular weight, but the branching is increasing. You can write branching as increasing.
Yeah, where can we know that branching is increasing? Which example? Second or third?
In this one.
Oh.
Actually, are not all the carbon in the one line, they are like this. They are coming out from one carbon and this is the most branched.
Okay.
So can you tell me which one is having the maximum surface area?
Linear one?
So the
Yeah.
So the
third
third
one.
one.
Which one? The more branched one or the linear one?
And
The more
branched.
branched one.
So the branch one will have less contact area. Suppose it becomes a sphere kind of thing. So one is sphere and another is sphere. You need to compare the contact area. And suppose if the molecule is linear, where the contact area between the molecules is more. If they acquire some spherical nature due to branching, are they touching each other at more number of places? Or the linear molecules, they are touching at more number of places?
So the linear is
The
touching at
linear.
more.
Yeah, the linear molecules, if the molecular weight is same, if the molecular weight is same, if the carbon atoms are same, if the halide is same, then you need to compare the surface area. The linear one is having more contact area with another molecule of its own kind. That's why it will have higher boiling point as compared to the branched one, which due to branching acquires a spherical nature and will have a very less contact area with another molecule. Is it clear?
Yes, sir.
So three things we discussed. So first is the boiling point between alkane, alkaline, and water. So this London forces, van der Waals forces are same thing. Dispersion forces are weakest. Dipole forces are stronger, and hydrogen bonding is stronger than dipole. So the boiling point is going to increase. Okay, water will have maximum boiling point. Now, another thing which we discussed was, suppose if the alkyl group is same, only the halogen is changing. As the halogen is becoming heavier, it will have more boiling point, higher boiling point. Okay, right? The third thing which we discussed is, suppose if the number of carbon atom are same, molecular weight is same, even the halogen is also same, then you will compare the surface area to check how much the molecules are in contact with each other. The linear molecule will have more contact area with another molecule of its own kind, so that's why they will attract more and the boiling point is going to be the highest. But you need to think of this contact area only if you have same carbon and same halogen, right?
So,
Yeah,
so this thing is only valid for isomers.
yeah, for isomers, correct.
Okay, so
Same formula but different branching, different structures. Okay, and in benzene isomers, you need to check their polarity for melting point. For boiling point and melting point, you need to check their polarity. Okay, so this is the ortho isomer, this is the meta isomer, and this is known as para isomer. If on the benzene two groups are exactly opposite, that they are para. Okay, and if two groups are adjacent, they are ortho. And if two groups are at first and the third carbon, then it is meta. These are the common names. The IUPAC names are 1,2-dichlorobenzene, 1,3-dichlorobenzene, and 1,4-dichlorobenzene. Okay, so which one is going to be most polar? Why I'm putting arrow on the Cl bond?
Ortho?
Yeah, ortho is going to be more polar. Yeah, because both the Cl are very close and they are trying to pull the bonded electron pair in same direction. So dipole moment is a vector quantity. You must have studied in your electrostats. Okay. So the overall effect of pulling is going to be stronger. Okay, and in this case, because the angles are a little bit increased, so the overall pulling is going to be less, and this is going to be a non-polar molecule. Sometimes we write this dipole as 0. So someone may ask you, this is having two polar bonds, CCl bonds, but in spite of two polar bonds, how come that this molecule can become overall non-polar? Yeah, tell me.
So because it
so
has
because they
got
are in the
more more angle between them, the angle is greater.
Yeah, angle is greater and they are exactly in the
they're in the
same
opposite.
line. Yeah, 180 degree exactly.
Yes, sir.
And if the two people try to apply force opposite exactly 180 degree, the resultant force will get cancelled.
0.
Same as the concept can be applied here, right? Okay. So this is going to be non-polar molecule. So the boiling point is going to be highest for ortho. Okay, and it is going to be highest for ortho because the ortho is the most polar, right? Clear? And what about melting point? Melting point is actually highest for para. Why?
Because they are opposite to each other.
Yeah, actually melting point, you are melting a solid. So how the molecule, in solid, the molecules are kept arranged in a symmetrical order. And if the molecule is symmetrical, they can be placed on each other very in a very good way. Okay, means very efficiently they can be packed together. So when you consider the melting point, do remember one thing. Okay, the melting point will be higher for the most symmetrical molecule, para, and the boiling point will be the highest for the one which is going to be the most polar. Okay, so this is most polar, so boiling point is highest for this one, while the melting point is highest for the most symmetric. Is it clear?
Yes, sir.
Okay, so just have this in mind. Okay, the other thing is density. These are actually some basic points you need to remember. These are very heavy. As you have more halogens attached or the bromine or iodine attached, these are having very heavy molecules, so the density, they are more dense. Okay, so if you have water, so these molecules will be below and the water will be up, and because they are insoluble in water. Okay, reason I already told you why they are insoluble in water. Okay, so these are the physical properties, right, of alkyl halide, and which physical properties, solubility, boiling point, melting point, and all the things are governed by the nature of the bond. Now we discuss the chemical properties or the chemical reactions. So how alkyl halides behave? Suppose if we talk about alkanes, they were having carbon-carbon bond and they were almost non-polar. They were not having any charge on any atom. Significant charge will not be there, only temporary charge may come up here or there, which may disappear. And they are very less reactive. That's why the alkanes are known as paraffins. Because they are very less reactive, they have little affinity. Paraffins have little affinity. Is it clear? So they are very, very, very less reactive. They do not show a lot of reactions because they are non-polar. But what happens with alkylites? What happens with alkylites? Alkylites are polar bond. Okay. And what's the outcome of this polar bond? Which type of molecules can, first of all, you need to think that will it help them to react more easily or with more difficulty as compared to alkanes? Yeah, Arpit? Imad?
So more difficult because they're non-polar.
Actually, suppose if there is no charge, then it is very difficult to break the molecule. But if the electrons are already getting shifted on one side due to electronegativity difference, okay, polar bonds are there, okay, so electrons are not in the middle, they are already shifted on one side, though the bond is there. So now it will be easier for us to break such bond. Okay, Is it clear?
Yes, sir.
So if the molecule has polar bonds, the electrons are not equally shared, they are actually more on one side, and because they are more on one side, the bond can be broken very easily because their electrons are already on one side, they are shifted. Okay. So because of polar bond, the polar bond is due to electronegativity difference. Chlorine is more electronegative of bromine or iodine. That's why the carbon halogen bond is polar. Okay, so it breaks very easily. And how will it break?
So will they attach the part of the separate molecule?
Which one?
Uh, will they attach because molecules?
Yeah, this is the molecule, okay?
Yes, sir.
But electrons are, the bond is there. We are bothered about this bond because this is the polar bond.
Okay.
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 And this bond can be broken more easily because the electrons are already on one side. Is it clear?
Yes. But sir, if the electrons would be in the middle, then what would happen?
Then it will be very difficult for us to break. Then where you will react?
Okay.
Okay, suppose if there is a group of friends, okay, and all the friends are equally friendly with one another, okay,
Yes.
so it is very difficult to break such group of friends.
Okay. Understood.
But among the group of friends, suppose if there are within, though all of them are friends, but actually suppose if there is a grouping, sometimes it happens, okay, if there is a grouping happening and there are two groups created within the friend circle, so it will be easier for us to divide them. Okay,
Okay.
so if in the bond also you need to think of the same thing, that if the electrons are not at the center, they are shifted towards one side, it will be easier for us to break such bond. Okay, and how they will break? They will undergo heterolysis easily. What do you mean by heterolysis? Anushka, Arpit, tell me. Heterolysis. Heterolysis and homolysis. Yeah. What do you mean by heterolysis? Any idea, Anushka? Arpit?
Breaking of different
Also.
bonds.
Yeah, heterolysis means when you are breaking the bond between two atoms, the electrons are taken away by one of the atom. So heterolysis means you will break it like this. Okay. Is it clear? Imad, Arpit?
Yes, sir.
Yes.
Clear.
So because they have polar bond, they can be cleaved more easily. But so there is one more thing, and that is the type of reaction which we are going to discuss now. And because the carbon acquire partial positive charge, the carbon halogen bond can undergo heterolysis very easily. The other thing is, Due to the partial positive charge, the alkyl group is susceptible towards the attack of nucleophile. So what are nucleophiles? Yeah, Anushka, Arpit, Imad, tell me, what are nucleophiles?
Are there electron-rich species?
Yeah, they are electron-rich species which have some unshared pair of electron which they can give, which they can share to any other atom. Okay. So, but that another atom need to have positive charge so they can attract the nucleophiles. So nucleophiles are electron-rich nucleus loving species. As the name indicates, so nucleus is positively charged. So nucleophiles should have electrons so that they can give share those electrons with the to another atom. Okay, so that's why they are called nucleophiles. So for example, nucleophiles you are having Cn minus. They can be neutral also. Ammonia is a nucleophile. They have pair of electron which they share. Varies hydroxide and OH minus is a nucleophile. Water is a nucleophile, but water is a weak nucleophile because it is neutral. Okay, is it clear? So water, oxygen, just now we have seen, Arpit, that they have delta negative charges, partial negative charges, so it can come and give away its lone pair because it is just sitting ideal. The lone pair is a pair of electron which is just sitting ideal, and this oxygen can share its lone pair, so it is behaving like a nucleophile. Another example of nucleophile, can you give me more examples of nucleophile which we will study in this chapter? Yeah, Anushka, Arpit, you can try. Imad, some more examples of nucleophiles you can tell me. Any example? Any more examples? NO2 minus, okay. SH minus,
Br minus.
yeah, Br minus, I minus, yeah, correct. Okay. Sometimes you have H minus also. Yeah, Cl minus. But these are actually weak nucleophiles because they are very stable. Okay. Nucleophiles also have different reactivity. The one which are strongly negative or they are very reactive. Okay. OCOCH3 minus, that is the acetate ion, which is the nucleophile. Okay. Is it clear? A lot of nucleophiles are there. So this one, or sometimes you have the nucleophile carbon atom also as the nucleophile, right? So a lot of nucleophiles are there, and these nucleophiles now they can find a way to attack on alkylites. And who is guiding them? Who is guiding them? The partial positive charge on the carbon atom, which is directly connected to the halide. That is actually attracting these electron-rich species. Is it clear, Anushka?
Yes, sir. Clear.
Right. So this is nucleophile. This is a general way to write. So I will write a general in a very general way without mentioning the exact nucleophile, without mentioning the exact alkylite. Okay. So suppose this carbon is having delta plus and X is having delta minus. So this nucleophile will get attracted toward the partial positive charge, Imad, of the alkyl group, and it can come and form a join itself to the alkyl group. It can give its lone pair. Okay, right? Is it clear? But there is one thing which we should know, that the carbon is a second period element, and carbon can make only 4 bonds. So how will it be possible, Arpit, that if the nucleophile is coming and getting attached to R, how will it be possible? Do we need to do something extra, or we just bring the nucleophile and get it attached to the carbon alkyl group? Yeah, Arpit. Yeah, do we need to do something extra?
Yes.
Yeah, what else we need to do? I will give you a hint. Yeah, what this arrow is indicating. Suppose MEI, if the nucleophile is coming and giving away its electron pair, it is forming a bond with the carbon. Carbon can make only 4 bonds, being a small atom. So if the nucleophile is trying to come and join in, there should be some other group which need to come out. Otherwise, we will have 5 bonds. Is it possible, Anushka, to have 5 bonds on the
No, sir.
carbon? No. So in order to keep the bonds 4, what we need to do?
So we'll need to remove one so that.
Yeah, we need to remove an atom. And which atom do we need to remove? Who can guide us? Actually, the atom which is actually already polar, okay, which is already trying to pull the electron, bonded electron density, that we can easily remove. Okay, is it clear? Because the halogen can be removed very easily. Okay, a halogen, because the halogen is already trying to pull the electron. So what? And now halogen can pull that electron completely and get separated, because the nucleophile is coming in and bringing its own electron pair and joining itself to the alkyl. Is it clear or not? Himad,
Yes, sir.
Anushka. So what type of reaction is this?
Sir, nucleophilic substitution.
Yeah, what type of reaction is this?
Nucleophilic substitution.
Yeah, this is a substitution reaction. So let me decide with respect to the name. So is it addition? Is it elimination? Is it substitution? Okay. So it is a substitution reaction, because one group is replaced by another group. So it is a substitution reaction. And who is doing this substitution? Who is coming and pushing away the one of the
The
halide?
nucleophile.
Yeah, nucleophile. So it is nucleophilic substitution reaction. Is it clear? So this is the main heart of the discussion. This is the main heart of the discussion, and it is that alkyl halides have polar bond, because of, and it is that everything started from the electronegative difference, which resulted in polar bond, which resulted in partial positive charge on the carbon, and that partial positive charge on the carbon led the nucleophile, that attracted the lone pair of the nucleophile. Okay, that so the nucleophile came in and gave its electron pair to the carbon, and the carbon can form only 4 bonds. So if the nucleophile is attaching, the halogen is going to come out. Okay, that's what we have done. Okay, so these reactions are known as nucleophilic substitution reactions. It is a very, very, very important class of reactions, though we will study in this chapter, but they are not the part only of this chapter. They will be studied in a lot of subsequent chapters also. Okay, is it clear? So nucleophilic substitution reactions, I hope this is clear. And so this is just the introduction. We will study how it will happen and what are the different mechanisms by which it can happen. But it is as common as addition and subtraction. Okay, so addition and subtraction we use everywhere. Okay, so nucleophilic substitutions are also very common. And what's the advantage? These substitution reaction on alkyl halide will let us prepare many new compounds. You can take alkyl halide, and because the halide can undergo substitution very easily, so you can prepare a lot of another compounds. Okay, by displacing the halogen by the nucleophilic group of your desire which you want to connect. Is it clear or not? So nucleophilic substitution reactions. So yeah, there are two types of nucleophilic substitution reaction. Can you tell me what are those two types?
So SN1 and SN2.
SN1 and SN2. And what's the difference?
So SN1 is monomolecular and SN2 is bimolecular.
Yeah, okay. Let me give you a very common life example. Suppose if this is our house, okay, and one guest is already sitting, okay, and this house is very small, only one guest can sit at a time, okay, and new guests are coming in. So what are the two ways by which it can happen? What are the two methods by which it can happen? The guest can't come in and sit, the new guest, guest number 2 and the guest number 1, they can't come in and sit along with the original guest, okay, because the house is very small, let's say, suppose. So what we need to do, only one guest can be there at a time. The one way is this, the new guest which is trying to arrive can come in, okay, and the guest which is already sitting in the house, they can leave simultaneously. Okay, it can happen simultaneously. One guest is leaving, there are two doors, imagine one guest is leaving, another guest is coming, simultaneously it can happen. Okay, so two guests are simultaneously involved. Okay, there is one more way. This is the method 1. Imad and Arpit, are you getting what I am trying to say?
Yes, so
Yes, sir.
So simultaneous arrival and departure. Another thing is, so this is option 1. So simultaneous arrival and departure. There are two guests which are simultaneously involved in the whole process. One guest is leaving, another guest is coming. So this type of reaction, if we compare it with the reaction on alkyl halide, this is SN2. Bimolecular substitution, nucleophilic. Bimolecular means two things. Substitution is happening nucleophilic because nucleophile is displacing, and bimolecular means two molecules are involved. Okay. Is it clear?
Yes.
There is one more way by which it can happen. What could be that way? Suppose the guests which are already sitting in our house, they can leave. They can come out of the house. Guest number one, which are already sitting in our house, they can leave the house, and then now the new guest, guest number two, they can enter after the initial guest has already left the house. Okay. So, but why can't we have the second guests come in before the departure of guest number one? That is not possible because the house is very small. Okay. And in this case, I am comparing the house with carbon atom because carbon atom cannot have 5 bonds. So we can't bring in the nucleophile and let it join on the carbon atom without breaking away any of the group. Okay. So either you need to do one thing, that you need to move the guest which is already sitting out of the house, and the guests which are coming, you can let them in simultaneously by two opposite side, two opposite doors. Okay. Okay. One is for the departure and another is for the arrival. That is SN2. Okay. And suppose if you can handle both the guests one by one. The guests which are already sitting, you can so once they leave the house, okay, and then the new guest can come. Okay, that is one by one, first leaving, then the new guest can come. That is SN1. Is it clear or not?
Yes, sir.
Okay, SN2 and SN1 reaction. So who decides how the reaction is going to happen? That depends upon the nature of the alkyl group and the nature of the nucleophile. So let me quickly go through first SN2 reaction. Okay, SN2 is substitution. The full form is substitution. This is the actual way of writing. Nucleophilic, bimolecular. Substitution, nucleophilic, bimolecular, SN2. Okay, this is a full form. And how it happens, let me give you one example. Suppose if you have taken CH3Br, this is the substrate. Substrate is the alkyl halide on which the reaction is happening. You have taken KOH, aqueous, okay, and the nucleophile is OH minus, because K plus is just the spectator and it will not participate in the reaction. It is already plus and it is just going to sit ideal. Okay, but we need to take a complete compound. Okay, so KOH, OH minus is a nucleophile. Yeah, is it clear? And this OH minus will come in and it will push out simultaneously the leaving group, and the leaving group is none other than the Br. Okay, so we have OH and CH3, and the Br minus will come out, but the Br minus we are going to write it with K plus. Okay, that's the way we are going to write it. So this is a nucleophile. Okay, the nucleophile is the substance which will come in and share its electron pair, unshared pair of electron to the carbon atom. Okay, this is the product. I will write it like this. Okay, this is the product which is formed after substitution reaction. And the Br minus is the halogen. Actually, it is known as leaving group. Because it has left. Okay, it has the halide. Actually, it was already polar. So it came out by taking away the electron pair. Right? So this is the reaction, but how it happens, but actually this nucleophile is a bit strong. Okay, so what it will do, it will approach the carbon atom. Okay, suppose if a strong nucleophile is there, what it will do, it will start attacking the carbon, the positive charge of the carbon. This positive charge serves as an invitation, okay, to come and attack. OH minus is there. Okay, so I will show everything by arrow. These arrows are actually put to show how the group is giving its electron. So this is going to come in and give its electron pair, and the Br is going to come out. So how many molecules are involved in the reaction? Two molecules. Okay, one is the nucleophile, another is the alkylite, which is known as substrate molecule. Is it clear, Anushka?
Yes, sir. Yes.
And it will happen in just one step. Just one step. It will happen, Imad. But if someone says, okay, it is happening in the one step, the nucleophile comes in and push away the leaving group out of the structure. Okay, so this is the answer in just one step. And the Br minus came out. But if someone asks you, okay, this is one step reaction, it is happening in one step only. So suppose if you are able to take the picture of in the middle of this whole thing when it was going on, so how the structure will look like? Okay, the structure will look like this. It will look like this. If you take a picture of the whole thing in between when the reaction is not complete, it will look like this. So what I have drawn, this is known as transition state. Is it clear? Means it is showing the transition of reactant molecules to the product molecules, how they are getting converted, and what is happening in the middle of this whole thing, in this middle of this whole messy situation, what is going on. So you can see this is the before the reaction has started. So I have shown everything with the help of the arrows. Okay, and once the reaction start, the OH minus will come in because it is strong base. So it will come in and start forming a bond with the partial positive charge of the carbon atom. Okay, it will, so this bond is, the nucleophile is trying to form the bond with the carbon. So this is bond formation. Arpit, is it clear?
Yes, sir.
And because the carbon can make only 4 bond, it can't accommodate and some extra electron. So someone has to pull its electron and get out of this carbon molecule. Okay, this alkylate molecule. And who's going to come out? The one who is already polar. So this electron through which the Br was bonded, this is trying to push, take away the electron pair and get out of it. So this is bond breaking. Is it clear? Bond formation and
Yes.
bond breaking, and both take place simultaneously in SN2 reaction. That's why 2 means bimolecular, means 2 molecules are getting involved in it. Is it clear, Imad?
Yes, sir. Yeah.
So you can write simultaneous bond breaking and forming.
Sir, can you scroll up? Just I wanted to note something. Look,
More.
enough. No, sir, enough.
Yes, simultaneous bond breaking and forming. Okay, and the reaction just complete in one step. So, but one step actually two molecules need to collide, then only the reaction will happen. Okay, so that's why it is known as bimolecular. Molecularity is the number of molecules which need to collide together in order to result into the product formation. Okay, so I will list down all the points. Yeah. Yeah, Iman.
No, nothing, sir. I just told. I've written that.
Yeah.
Hold on.
So I will list down all the features of this SN2 reaction. Single step, single step reaction, they just the nucleophile molecule just hit and push out the leaving. This is not, I have shown you this. That doesn't mean that this is a two-step, right? Clear? This is not a two-step. This is just a single step reaction. It happens, but if you try to take the picture in the middle, how it will look like this. Okay, that's for that I have shown you this. So single step reaction. And these single step reactions are known as elementary reaction. Okay, and in the single step, the nucleophile molecule is colliding with the substrate molecule. Alkylite molecule mean two molecules are actually collide together to need to form the product. They need to collide together. So this is known as molecularity. So it is known as bimolecular. Okay, bimolecular means two molecules are simultaneously colliding and to form the product in one step only. That is happening. And suppose if you try to find the rate or the speed of the reaction, okay, the rate of the reaction is actually directly proportional to the concentration of the substrate. Substrate is alkyl halide. Concentration is mentioned in square bracket into the concentration of nucleophile. So the rate is actually directly proportional to the concentration, because if you are taking more number of molecules, more concentrated, okay, the probability of collision is going to increase that, because the molecules are randomly moving, and if you take more moles of molecule in liter, okay, they are going to collide, going to collide more often. So the rate is directly proportional to the concentration of the CH3PR and as well as of the concentration of CH3 of the nucleophile. If you double the concentration of nucleophile, the rate of SN2 is going to get double. Is it clear, Anushka?
Yes, sir. Clear.
Arpit, Iman?
It's clear.
Okay. So actually the concentration to the power 1, concentration to the power 1, and how the concentration of both of them play a role, because they are colliding. More concentrated means more number of particles per unit volume and more collisions you can expect from them. So more rate of reaction, more quickly the reaction is going to happen. Okay. And if you add the power of the concentration, okay, that is called order of the reaction. Order of the reaction, we have a complete chapter, chemical kinetics. Order of the reaction is the sum of the power of the concentration terms in rate equation. So this is second order. Okay, how come second order? 1 plus 1, because there is one concentration term for the substrate or the alkylite. There is one concentration term for the nucleophile multiplied together. Okay, so the total power of the concentration is 2. One for substrate, one for nucleophile. So the overall order is 2. Is it clear? So order is the sum of the powers of the concentration term of the rate equation appearing in the rate equation. Okay. So it is second order reaction. It is bimolecular reaction. In bimolecular reaction, simultaneously bond breaking and forming are taking place. It is elementary reaction. It is happening in single step. Okay. And actually, how the rate is going to get affected? What are the factors which affect the rate? Rate of SN2 means how quickly. It depends upon the concentration. Okay. Of the substrate itself and the nucleophile also. Okay, but apart from the concentration, the rate also depends upon the structure of R. Structure of Rx. Okay, structure of Rx means CH3 how the structure of Rx is changing. For example, we take CH3Cl, CH3, CH2Cl, and so I'm keeping the alkyl. I'm changing the alkyl group and I'm keeping the halogen same. Is it clear? So where the reaction is going to occur occur fastest, where it will get completed most easily. I have taken their concentration same. Suppose if I react CH3Cl with OH minus or KOH, aqueous KOH, or if I react with ethyl chloride with aqueous KOH or NaOH, or if I react this isopropyl chloride with aqueous KOH or tertiary butyl, what do you expect where the reaction is going to get, or will they take same amount of time? Assuming I have taken equal number of moles and concentration of everything, temperature also is same. Yeah, Anushka, Arpit, Imad,
Yes, sir.
where it is going to get, where it will get completed very quickly. Tell me. What can you say about their speed? Arpit, Imad, Anushka? Yeah.
So it will be more faster in the first one,
It will be,
faster in the first.
it will be fastest for CH3Cl. And as Imad and Arpit, you are increasing the branching, increasing, you are putting, you are replacing these hydrogen by methyl groups. Okay. The reaction is becoming more and more branched, it is becoming more and more bulkier. So the speed of the reaction is going to come down. And the reason is very simple. I will draw this structure. Arpit, is it clear or not?
Yes, yes.
So this is the reason. Suppose if the Cl is there and if the nucleophile is trying to come in and give its lone pair, it need to have the access of the carbon, and it can come very easily because the three groups which are not participating in the reaction are just hydrogen atoms, small hydrogen atoms.
Sir,
They-
will its speed depends on branching of these examples, or just
It will depend upon branching also, it will depend upon many other things also, but branching plays a most important role. Okay, so this is going to be fastest because these groups are very small. Is it clear? They are just protons. Very less steric hindrance. This is known as hindrance. In organic chemistry, it is known as steric hindrance. But what happened to this? Look here. These three methyl groups. I have just written them CSC, but they will be like this. The hydrogen will also be coming out. Can the nucleophile Arpit come in and access the carbon atom? Will that be possible? Will that be easy? No. So this is primary carbon. This is 0 degree. The methyl is 0 degree because it is not connected.